Hey everybody, just gonna wait another minute or two for people to join in. But thanks for joining us here. How's everyone doing today? Sweet, doing great. Nice, Leon. That's good to hear. I'm doing pretty good too. So we'll probably wait one more minute, wait for some other people to trickle in, and then we'll go ahead and get started. Doing great. Nice. Nice, Max. Okay. I think we'll go ahead and get started here. We have enough people. Okay. All right. Welcome, everybody. Thank you for joining us. My name is Michael. I'm going to be the host for this webinar today. So for those who haven't interacted with me yet or haven't seen any of my webinars, I'm a cloud solutions architect for MassDriver. MassDriver is a single pane of glass for managing infrastructure and services from design through day two operations by enabling developer self-service. During the webinar today, I'm going to have some members from my team who are going to be in the chat answering any and all questions. Okay, so today we're going to be talking about observability in Kubernetes, specifically using Prometheus and Grafana. So we're going to talk about like what observability is in Kubernetes, what it really means to have observability into your Kubernetes cluster. We'll set up Prometheus on a blank Kubernetes cluster that's going to be up and running for monitoring. And then we're going to be talking about some more of the critical metrics to track, such as CPU or memory. And then we'll close the webinar by using Grafana to create a custom dashboard to monitor some of these metrics. So before we dive in, let's go ahead and talk about some of the terminology that I'll be using in today's webinar. And then those two pieces of terminology is going to be Prometheus and Grafana. So if you haven't heard of either of these services before, Prometheus is an open source tool for monitoring, alerting, collecting, and organizing metrics as time series data. It features a powerful query language called PromQL and a scalable architecture, making it ideal for monitoring complex systems. Grafana is an open source platform for data visualization and analysis, allowing users to create interactive dashboards to track metrics, logs, and traces. It supports a wide range of data sources and provides extensive customization options for comprehensive monitoring and reporting. Okay, so observability, let's talk about this for a minute, just so we get some of the fundamentals down. Observability is more than just monitoring metrics like CPU or memory usage. While those metrics are still important, they don't exactly paint the whole picture for what could be going wrong in your environment. The best place ability, which are logs, metrics, and tracing. When we build out a logging solution, we want to gather information and log events as they happen. This helps us troubleshoot issues. We want metrics because metrics allow us to measure performance data. There are four key metrics that we want to track in any system, and they're known as Google's four golden signals. They're latency, traffic, errors, and saturation. Latency tracks the time it takes to service a request. Traffic is a high-level measurement of overall demand. Errors represent the rate at which requests fail, and saturation is a measurement of resource usage as a fraction of the whole, typically focused on constrained resources. Now, what that means is, let's say you're typically utilizing 60% of your CPU or your memory within your application, and everything works with that percentage of utilization. But you need to know how your system is going to react to using 80% or 40%. Are you going to experience any issues by changing the fraction of your utilization? So that's what saturation is referring to, is let's find out how our system reacts to changing the fractional usage of our environment. And then last but not least is tracing. Tracing logs end-to-end request performance, meaning you can gain insight to the flow of your application and how that's working. So without further ado, let's go ahead and jump into a Kubernetes cluster. So I'll go ahead and share my terminal here. And this is the stage. Okay. Let me go ahead and move this over. So now that we have the basics down, let's go ahead and set up Prometheus on a brand new Kubernetes cluster. I have a fresh instance of Minikube configured that we can play around with today. So the first thing that I want to do is set an alias for Minikube kubectl, just so I don't have to keep typing that with every command. So I'm just going to do alias mkk, it's just so we're on the same page, Minikube kubectl dash dash. Okay, so if I do mkk get pods dash a, we're going to see that I just have some basic kube system pods set up. Nothing else is within my cluster. Let's go ahead and install the kube Prometheus stack. I'm going to link the GitHub repo for this kube Prometheus stack here in the chat. And what this kube Prometheus stack is going to allow us to do is download and install more than just Prometheus onto our cluster, but also other services such as Grafana and Alert Manager. It's an all-in-one package. And the command I'm going to run to add this in, and I might already have, let's see, Helm repo list. Yeah, so let me do Helm repo remove. I'll just remove this real quick. And Helm repo list. Great. So let's go ahead and add this particular repo into our Kubernetes cluster. And it's been added as a repo. And if I do Helm repo update, we'll just go ahead and make sure that we have the newest version of that chart. Perfect. Now we can install. So we're going to do Helm install Prometheus, namespace Prometheus, create namespace, and I'll walk through what this command is doing after I've typed it out. Prometheus community / kube Prometheus stack. So what we're doing here, if you're not familiar with Helm, is we're using Helm to install a release. So we're saying Helm install, we're naming this release Prometheus. We're then specifying to install this release into a namespace within our cluster called Prometheus. And then we're also adding the flag to create the namespace if the namespace does not exist, which it does not. And then we're specifying within the Prometheus community, we want to use the kube Prometheus stack Helm chart. And then we'll go ahead and hit enter, and then that'll go through the installation process. So like I said, the kube Prometheus stack is a collection of Kubernetes manifests, Grafana dashboards, and Prometheus rules, alert manager, combined with documentation and scripts to provide an easy way to operate end-to-end Kubernetes cluster monitoring. So we're just going to wait for this to come up. Oh, that disappeared. Sorry about that. And this should come up in just 1 minute. Just taking a look at the chat to see if anybody has posted any questions. Okay, looks like it is deployed. So now if I do mkk get pods namespace Prometheus watch, I should be able to see each of these pods going through the process of coming up. Now, while we wait for these to come up, I did want to mention just off to the side that we do have a Mass Driver community Slack available for anyone to join. I'll go ahead and post a link to the chat. That terminal will hide for a second while I post this link. So the community Slack is a growing community of engineers, developers, and enthusiasts who want to share their knowledge and experience of Mass Driver with other customers and things like that, discussing Mass Driver best practices, platform engineering. So that's a great community if you're interested in that. And our pods should be almost up here. I think we're waiting for 1 to 2 more. And then we'll just check it without the watch. So we have 2 more pods waiting. I'm just gonna look at the chat here, see if anybody has posted any questions. And then we have, looks like 1 more pod that we're waiting. There we go. That should be all of them. Excellent. So now that all of our pods are up, we can find out what services are deployed with this Prometheus stack by doing mkk get service namespace Prometheus. Service, I spelled Prometheus wrong. Prometheus. There we go. So as we can see, we have Alert Manager, Grafana, we have some Prometheus kube operators, and then we have the node exporter. So this is everything that we need, sort of like an all-in-one solution for monitoring these complex systems. To access Prometheus, what we want to do is access the Prometheus operated service, which we can find right here. And I can do that by port forwarding to that service. I can do mkk port forward namespace Prometheus, and then I want to do service Prometheus operated, and then I'm just going to map port 9090 to 9090. Oops, I spelled Prometheus wrong again. Prometheus. There we go. So now let me go ahead and share a screen here. Now if I open localhost 9090, and here we go. So I have this browser set up. I'm accessing Prometheus from my cluster. Prometheus deploys with default rules and alerts. If I click through the alerts, I can even select the inactive ones. These are all the alerts that deploy with the kube Prometheus stack. Now, I can make changes to these alerts and rules as I see fit for my application and to meet whatever requirements I have. Clicking on this alerts window, like I said, shows you all these alerts that come configured with the cluster. And most importantly, if I remove the inactive ones, I can see which ones are firing. Like for example, this watchdog one. Expanding this fired alert shows me a lot of additional information, such as, the severity of that particular alert. If I expand this other one, we have other severity types like warning and critical, things like that. I can get more information about exactly what's going on when the alert was fired. And then when it resolves, it can give me information about that resolution as well. Now I can click on the graph button here, and then we're gonna see that I can just add in an expression to find out what's going on for a particular metric. So if I type in node CPU seconds total, for example, and I execute, we're gonna see a lot of tabled results here about CPU seconds being used. I can switch over to the graph tab, and then I can shorten my time to the last 15 or even 5 minutes to find out what these metrics are doing represented in a graph format. Okay, so let's say I don't know the exact expression that I want to find, but there's an alert that contains that expression. If I do kube scheduler down, for example, I can click on that particular expression and I'm going to see, a graph or a table representation. That may not be the best one. Let me go ahead and switch to target down, for example. Now we're seeing some more data coming in through the table. I can switch to graph format, shorten the time span, and we're going to see a better representation of what's going on with that particular metric. And you can see that I can customize my expressions however I need to get the data that I want from the alerts and rules that are configured. All right, so we took a look at Prometheus. I do want to take a look at Alert Manager real quick. I haven't mentioned this really in the objectives just because it comes with this Prometheus stack, but Alert Manager is a really nice dashboard to be able to check out. It has some cool tools. So let's go ahead and switch back over to my terminal. If I can find it. We'll add this to the stage. So viewing the Alert Manager dashboard, if I do mkk get service namespace Prometheus, we can see that I have the Alert Manager operated service. So I can do the same thing with port forwarding here. I can do mkk port forward namespace Prometheus. Service/alert manager operated, and then we can map this to port 9093, which is what it's on, 93. And now we're port forwarding that. So I'll go ahead and switch back over to my window here. If I can find it, Prometheus, add this in. So we'll do localhost 9093. Okay. So this is the Alert Manager dashboard. In this dashboard, we can do some cool things like if we wanted to silence an alarm, we could create a silence here by matching an expression within the filter. Once that alert is silenced, no notifications are continued to be sent out with that alert. We can do some other cool things with Alert Manager, like configure SMTP so that we can get emails, or even configure getting alerts within Slack, things like that, all within Alert Manager. So this is how you would access it if you wanted to customize or create a new silence through this window right here. So now that we have a general idea of what the Prometheus dashboard looks like, how to access it, same thing with Alert Manager, what I want to do is I want to create a new alert rule for Prometheus. I have an idea of what I want to track from my application, and I need to create a new rule to do that. So we're going to go back into the terminal and create an alert rules YAML file that we can add an additional group. It's called an alert group, and then add some new rules under that so that we can actually see that within Prometheus. So we're going to switch back over to my terminal. And then add that to the stage. Okay, so we're going to close this off here. Go ahead and clear this. So what I want to do is create a new file, alert rules.yaml. And this is a blank file. I'm going to go ahead and copy in a template that I just found online. Quick Google searching for a couple of simple alert rules. If I make this smaller, we should be able to see more of it. So this is, and let me clean this up a little bit. I don't know why it formatted like this. Luckily, the YAML file is pretty small, so just take a second. Okay. I'll make it a little bit bigger. So this is just a simple alert rule where I'm go ahead and I'm adding a Prometheus rules map to my existing Prometheus configuration. So I'm essentially appending my Prometheus config map with these new alert rules. We can call this group webinar test, and then instance low memory. We can call this instance low memory test, just so we can decipher it within the alert rules. I do need to update this line here because of how JSON and YAML gets converted between each other. And then we'll call this instance down test, and that should be good. So if I save that, and the next thing that I want to do after saving that, I can cat alert rules, make sure it got saved properly. Yep, sweet. So the command that we want to run now is a Helm upgrade command. Basically what we're doing is we are upgrading our current installation of Helm with this new addition of the alert rules. And to do that, we're going to use Helm upgrade and then -- reuse values. Then we're going to set the path for alert rules. Then we're going to reference the Prometheus release name. And then we're going to reference the Prometheus community / kube Prometheus stack Helm chart. And then we're going to specify the Prometheus namespace and hit enter. So this should only take a minute to upgrade. And then we'll go ahead and see a confirmation. Just a minute. And then after this, what we're going to do is we're going to go back into the Prometheus dashboard, and then we're going to find the rule that we just created in there. So we can see that the Prometheus Helm chart has been updated, status deployed. So now if I port forward that Prometheus dashboard again, we should see it come through. Port forward, namespace Prometheus, service Prometheus, operated 990. Okay, so if I open up and switch my screen here. Quick question, will there be a recording available anywhere? Yes, so we are saving a recording of this webinar on our YouTube channel. Basically a few minutes after the webinar ends, it'll be uploaded to our YouTube channel. I believe a recording is also going to be stored within LinkedIn too, if you're following within LinkedIn. So either one of those options, the entire recording for the webinar is going to be available to watch. All right, so we just added those alert rules within our Prometheus installation. So if I go into alerts, we're going to see these two new alerts that I just created: instance low memory test and instance down test. So I've gone ahead and I've created these alert rules with the expressions needed to represent what those triggers are going to be if those alerts end up firing. You can see there's a lot of metadata that came in by creating those alert rules, and they're instantly available to start determining if I have issues or not. So now that those two alert rules are added in Prometheus, we've installed and taken a tour through Prometheus, we're ready to move on to Grafana. Now, to spare you a bunch of context switching within monitors, I'm just going to close this connection from Prometheus and open up the port forward connection for Grafana in the background. I'll share the command that I'm using to do that in the chat if anybody's curious to what the command looks like. But just to save everybody from having to do a bunch of screen share switching, I'm going to take care of that for you real quick. All right, so now if I go to localhost 3000, we can see that this is loading the Grafana dashboard for my Kubernetes cluster. Now the default login is going to be admin and then prom-operator. Oops, prom-operator. And here we go. This is a basic, essentially out of the box Kube Prometheus stack Grafana setup. If I click on the menu and click on my dashboards, we do have a list of dashboards that come out of the box with this Kube Prometheus stack. And that's why this Helm chart is so cool, is because, typically if you were to install standalone Prometheus and standalone Grafana, you would have very bare bones configurations. It would take a lot more work and know-how to know how to configure everything together. The Prometheus stack, we're not sponsored by them or anything. It's just a really awesome Helm chart to get started, to have all the 3 services that you need for really Prometheus, Grafana, Alert Manager, and the node exporter. So these dashboards, like I said, come default with the Helm chart. If I click on one like the core DNS dashboard, for example, we're going to see some data coming in for my Minikube local instance. I can switch to the last 15 minutes and we're going to see, core DNS getting some requests coming in because I'm accessing these dashboards. If I switch to another dashboard, like compute resources for a pod, for example, we're not going to have any data coming through because I actually don't have anything running in this cluster other than Prometheus. What I do have is an application running on a Kubernetes cluster that I've prepared for this webinar. This is an application that I wrote, intentionally sluggish, just generates a new quote and a new image every time I hit the button. I've added some logic in there to make it incredibly slow and sluggish when I try to generate a bunch of new quotes at the same time. So what I want to do is I want to switch to using my Kubernetes cluster with my application that I prepared for this. And then we can take a look at a Grafana dashboard where data is actually coming in. So let me go ahead and switch my my kube config. So I'm gonna do export kube config, and this is just in the terminal in the background that I have set up, and then I'll do mkk forward, or it's kube forward. Perfect. So now if I do localhost, there we go, localhost 3000. Okay, so now we are accessing a Grafana dashboard where I have my running application. So if I log in, it's gonna be admin, and then I set Grafana as the password. And then now we're accessing a dashboard where I have an application and data is gonna be coming in. If I switch over to like core DNS dashboards, we're gonna have a lot more data with a lot more requests coming in. In fact, if I switch this back to the last 5 minutes, and then if I switch to my app and I just click a bunch on my application, get a lot of requests sent through, I may even cause my application to crash. We'll check back on this dashboard in just a minute, but we're gonna see all of the responses and all of their request metrics spike up. So while this is spiking up, we're also going to go through this process of creating a new bit dashboard. Now, there are resources out there where you can add existing dashboards that other users have created, and I'm going to touch on that towards the end of this process. But I do want to take you through creating a blank dashboard to be able to understand what the process looks like for setting up custom types of metrics and stuff like that that you need to see specific to your application. Because that's an important feature within Grafana, is being able to customize the metrics and the traces and the logging and stuff like that that you need to see for your specific application. So I'm going to go ahead and set that up. We can see everything is starting to spike with all of those requests. And we're going to let that run in the background for Mm, okay. Can you guys hear me now? Sorry, I think my headphones timed out. And you guys timed out a couple minutes ago. Okay. Sorry about that, guys. My headphones, they just decided to time out on me because I wasn't listening to anything. So where did I lose you guys? And I'll go back. I apologize about that. Um, was it in the customization of the panel configuration? And I can backtrack into that. 6 minutes ago. Okay. So I'll go ahead and kind of resum of what I just talked about, what we just went through. If some of it's repetitive, I apologize. I don't want you guys to miss any of this information. So what we did is we created a new visualization within our new custom dashboard. I wanted to track the namespace performance because all of my microservice architecture is going to be within that single namespace. So I've gone ahead and added a metric for namespace CPU, and there's tons of namespaces available to be able to pick from, or sorry, there's tons of different metrics available to be able to pick from that you can go ahead and add label filters to be able to query and get the information presented the way you want it. And I've gone ahead and added a label filter specifically for namespaces, and I set it to default, which is where I plan all of my microservices to be deployed to, which gave us this graph, this representation of how many CPU requests are being handled within my namespace. I then went ahead and added an option to change the legend label from a verbose output, which basically spits out what my expression is, to a custom label, a human-friendly readable label, where I'm saying this is my default namespace. I then went into my panel options. I gave my panel a name specifically so I know what's being tracked in this panel, and I called it namespace CPU requests. I then went down and modified the label for my y-axis. Now I need to know, what these numbers on the left here represent, and I can label CPU requests. This is how I know exactly what that line is representing. Human friendly, easy to be able to identify what's going on by viewing this dashboard. I can pass this dashboard off to a coworker who has no experience or no knowledge about building a dashboard, and they can see exactly what's going on in this environment. We then saved the changes. We named our dashboard app performance. And by clicking apply, I'm actually sent to that dashboard for app performance. So we can see this is for my default namespace. This is the namespace CPU requests panel, and it's tracking the amount of CPU requests that are being made within the last 15 minutes. Now we want to add one more visualization to this dashboard so that we can have a couple panels to get a better picture of what's going on. So we're tracking CPU requests. I also want to track memory requests. So I added a new visualization, and we're going to kind of go through the same process. It's going to be very similar, except I'm going to do namespace memory, and then we're going to do memory requests. If I select namespace, it's going to be default. We'll hit run. Now, without this filter, I'll just go ahead and remove it for a second. The same thing. We have a lot of different metrics coming through for all of our namespaces. I want it specifically for my default namespace because that's where my microservice architecture is going to land. Now, running this query, we see that we are getting a single namespace data back for memory requests, but it's in bytes. And I don't really want it in bytes. I'd like it to be in gigabytes. It's more human friendly. It's a better metric to be able to track and easily determine how much memory my applications are requesting. So what I can do here is I can switch to the code variant of this expression. Now this is the entire expression for this metric that I'm tracking, but I can add some customization to it. So I'm just going to do something pretty simple and a little bit barbaric. I'm just going to divide the result by 1 and then 9 nines after that. So 1, 2, 3, 4, 5, oops, 4, 5, 6, 7, 8, 9. So now if I run this, it's actually converting that result into gigabytes for me. I'm sure there's some more advanced and fancy ways that you can do this, but this one is definitely the simplest and the quickest. And then again, what I want to do is add a legend. So we're going to call this default namespace again, just so we know which namespace this is referring to. We can add a panel title, namespace memory request. And then we can add a label to the y-axis. We'll call this memory gigabytes. Cool, so if we click save, we're gonna save that dashboard change and click apply. So now we can see that we are adding additional visualizations to the same dashboard, and you can add as many or as little as you want to determine what you want that dashboard to represent. Now, what I can do is I can actually go into my application here, and I'll show this just for a brief moment. Now, this is going to be through Mass Driver, and I'm going to add this to the stage. So this is the actual application and the Kubernetes cluster that I have up and running. I'm just going to go into my quote generator app, and I'm going to change the resource requests around. So we're going to go from 4 gigabytes. We'll do 5.5, or I'll just do 6 gigabytes. And then I'll just deploy these changes. And I'll let that deploy in the background. I'll go ahead and share my dashboard again for app performance and add this to the stage. Now, when the deployment of that application takes place, which should happen in any minute, we're actually going to see this graph change because we're only tracking for the last 15 minutes. So that should just take a minute to go through. Now, if you want to skip the hassle, I'll talk about this while we're waiting for this application change to take place. If you want to skip the hassle of creating a dashboard, because creating a rich, fancy dashboard can seem kind of daunting, it can take a lot of time. There's a learning curve with it. Obviously, there are a lot more advanced expressions that we can do with PromQL, which is Prometheus querying language. We can make some super cool dashboards if you are well versed in that. Many of those super cool and rich dashboards actually exist on Grafana's dashboard marketplace. I'll go ahead and link that to the chat here. In case anybody's interested in checking that out. There's some really cool dashboards in there. You can filter by data source. So whether using Prometheus or Graphite or whatever your monitoring tool is, you can filter specifically for those tools and then find all the dashboards that you can run with those monitoring tools. Looks like my application is still trying to run. Oh, there it goes. I think it was sitting in queue, those changes. So now my application is starting to run. And while that's running, I'll go ahead and poke a little bit around Grafana while we're waiting for this metric to update. So we can do some other cool things with Grafana. We can set up alerting if we wanted to, custom alert rules, things like that. I'm not going to dive too deep into that just because we're waiting on the dashboard to update, but there's a lot of different connections that you can actually set up with Grafana that is outside of Prometheus. And yeah, like Lou mentioned, I'll even voice this on the call. If anybody's in the Los Angeles area or the Santa Monica area, we are hosting this outings and outages at Jameson's Pub tonight. If anybody's interested, Lou sent the link in the chat. It's just a gathering that we're doing. Should be a lot of fun, and we're going to keep hosting these gatherings. So yeah, there's a lot of different monitoring and metrics that we have available, data sources within Grafana to be able to pull from as long as we have them installed in our Kubernetes cluster. This is what makes Grafana so powerful and honestly kind of intimidating to set up in the first place. But it's important to have this type of tooling within our system so we can monitor health. All right, so let's go back into the app performance dashboard. And now we can see the results of our change. We had a spike of memory and CPU requests because of that change, and then it kind of leveled out. We set the CPU to 2.5. We set the memory to 6 gigabytes. All of that is being reflected within our dashboard. All right, so let me go ahead and switch back to this, and we can go through a recap. Okay, so yeah, to recap, we talked about what observability in Kubernetes really means. We set up Prometheus on a running Kubernetes cluster. We briefly spoke about some of the more critical metrics to track, such as CPU, memory, and Google's golden signals. And then we finished up by using Grafana to create a dashboard to monitor some basic metrics. So this actually concludes our webinar. So thank you so much for joining us today. I'll be sticking around to answer any questions. If you guys are interested in learning more about MassDriver, please reach out to me with any of those resources, or you can check out massdriver.cloud.